This is part 2 of chapter 5, section 1, and we're going to begin by talking about effective rates. And the idea here is that there are two different kinds of rates. There is the APR, which is the annual percentage rate, and in this particular problem, the APR, or the annual percentage rate, is 6%. Now we also have something else that we're going to talk about here called the effective rate. The effective rate is the actual increase of the money, which is actually 6.9%, which is a little higher than the annual stated interest rate of 6% because it's been compounded semi-annually. And to differentiate between those two numbers, 6% is called the nominal or stated rate, which is also referred to as the APR. And the 6.9%, which is the actual amount of interest that you draw, is called the effective rate. So the effective rate can be determined easily enough with this short formula here. And that short formula is that the effective rate, R sub E, is equal to 1 minus the periodic interest rate, which is R over M, and then it's raised to the M power, M being the twice a year that it's compounded in this case. And then from that whole quantity raised to the M power, then you will then subtract 1. And what the subtraction of 1 actually accomplishes is that it is the initial value. It accounts for the initial value or the initial deposit. In the case that we're talking about in the problem that we have above, that would have been the $1. So you're subtracting off the $1. You can use a TI calculator to calculate effective interest rates. It's actually on the same menu as the TVM solver. So just keep that in mind. And if you're trying to find the APY, which is the effective interest rate, that's the percentage yield, then you use the effective interest rate command. And if you notice here, it says that you need to enter two pieces of information. The first one is going to be the stated interest rate, compound interest rate, but it has to be entered as a percentage in this case, or as a decimal percent. And then after the comma, you're going to choose the number of compoundings per year. So for the one that we're looking at right here, the nominal interest rate, meant to be using a marker. The nominal interest rate, which is 3.35%, is your compound interest rate. And then the fact that it is compounded monthly tells us that it is compounded 12 times per year. And the calculator will give you the same answer as what the formula gave you, which is 3.409. With the arithmetic, in the formula, the calculator has all that stored, so you just enter the APR, or the annual percentage rate, or the nominal interest rate. And then the number of compoundings. And then what you get out of the problem then is your effective rate. In this case, it would be 3.41, or excuse me, 40% would be close enough. So 3.4%. So here we have Joe Viteri needs to borrow money. His neighborhood bank charges 8% interest, compounded semi-annually. An internet bank, on the other hand, charges 7.9 interest, compounded monthly. Which bank is going to give him the lesser amount of interest? So in the case of his neighborhood bank, we need to find the effective rate, which will access that menu on the calculator, and enter in the nominal or the annual interest rate, which is 8%. And then the number of compoundings, which semi-annually would be twice. And what we're going to see then, as we do those calculations on the calculator, is that his neighborhood bank actually charges 8.16%. Whereas with the internet bank, the effective rate is going to be 7.9%, and that's compounded monthly, so that's going to be 12 times, and that's going to be equal to 8.19%. Now, since Joe is wanting to borrow money, then his bank, his local neighborhood bank, has the better interest rate. Now, if Joe had been investing money, I hope it's apparent that if he had been saving money, then he probably should have gone with the internet bank because it's a little bit higher. But because he's borrowing money, then he wants the lower interest rate. And the next topic we're going to talk about is called present value. Present value is also what is referred to in your simple interest loans and your compound interest loans as the principal. But the idea behind present value is you're trying to figure out how much money you would need to put in the bank now to have some particular value of money in the future. So this is something that you might need to know. Like, for example, if you knew that you needed to have a certain amount of money to pay off a balloon payment on your mortgage, you would need to know how much money you would need to put in the bank right now and let it draw interest to have that amount to be paid off on a balloon payment. Or maybe you're trying to save for a down payment in 5 years on a house, and your grandma left you an amount of an inheritance, and you're trying to figure out how much of that inheritance that you would need to deposit right now in order to have that down payment on your house in the future. And please take into account that here again, we can find the present value of an account by using your TVM solver. And the example we have here for the TVM solver says that a zero coupon bond with a face value of $15,000 and an interest rate of 6% compounded semi-annually will mature in 9 years. What's a fair price to pay for that bond today? Today being the key. So notice here that our interest rate is 6%. The present value we don't know. So we're going to enter that as a 0. The payment is also going to be 0 because we're just going to invest a lump sum. The future value, it's going to be worth $1,500. So we'll enter the future value as $1,500. And it says that it's compounded semi-annually. So the payments per year of interest and the compoundings per year are the same. They're 2. And then the last thing it says is that n is equal to 18, and that's because we're talking about 9 years compounded semi-annually. So there's where the value of 18 comes from. So we hit alpha solve, and we determine then that the present value is $8,810.92. So that's how much the bond is worth right now. And at this rate, then we could fairly buy that bond at $8,810.92 and have a fair price for the bond. So our example from the textbook says that Tracy has to pay a lump sum of $6,000 in 5 years. So this is your future value. And 5 years is the amount of time it's going to be compounded annually. So that means n then is going to be 5 times 1, or just 5. And your interest rate, is 6.2%. And once again, what we're looking for is the present value, which we're going to set to be 0. And the payments, since we're only going to make a lump sum deposits, is also going to be 0. And your C/Y and your P/Y, again, both have to be the same. And since it's compounded annually for 5 years, then that's going to be 1. So at this point, once we've entered all of this into the calculator and we press alpha solve, we're going to get the same thing as a result of a formula, which is the formula for present value. And in this case, it would have been 6,000 divided by 1.062 raised to the 5th power for the 5 years compounded annually. And the compound amount turns out to be $4,441.49, which is our present value. So Stephen's need for a lump sum in $6,000. Stacy should deposit $4,441.49 now to have 6,000 in 5 years. And that concludes that problem. Now this is a second present value problem. So what you should do is try to follow my steps and look at your notes from your last problem and see if you can work this problem. So pause the recording, see if you can work out example 9, and then start back. So now that you've hopefully worked the example out, here is how you would have filled in your calculator. In 9 years, there are 2 times 9, which is 18 semi-annual periods. The stated interest rate is 2%. The present value is what we're looking for. So we're going to enter that as a 0. We're not going to make any payments. The future value is 16,000. And the compoundings per year is going to be 2 because that's semi-annual. And the payments of interest per year will also be 2. So once we've done that, and then we go and put the cursor on the present value, and then we press the alpha and the solve button, we will get the present value of this amount of money, which is $13,376.28. So for the future value of $16,000 in 9 years, with money deposited at 2% compounded semi-annually, our present value is $13,376.28. Now, the TVM solver can also be used to find how much time is required to achieve a certain amount of money. So in this particular case, going once again to the TVM solver, so in this situation, we can still use the TVM solver. What we're going to do is we'll enter the value for n, which is the number of compounding periods, as a 0, our interest rate, which is 5.25%, our present value is $24.50, and of course there were again no further payments made, just the lump sum, while our future value is $10,000. And because our interest rate is compounded quarterly, then both C/Y and P/Y are going to be 4. So then you go to the cursor, and you put your cursor on the 0 at n, and alpha solve will give you the answer that you're looking for. And alpha solve gives you a value of n, which is 107.86, which we will have to round up to 108. So that means it's going to take 108 quarters, and since there are 4 quarters in a year, we'll divide that 108 by 4, and we will get 27 years as the value of time that it takes to have $10,000 from an initial deposit of $2,450 at 5.25% interest compounded quarterly. So the TVM solver is actually quite a bit of help in this whole entire chapter. As long as you know any 3 pieces of information here, or actually any 4 pieces of information, then you can always find the last piece of information you need. Now, we also have something called continuous compounding. Continuous compounding has a rather different formula. What we'll do is we'll look first, before we do an example, at various kinds of compounding. For example, if you have a problem and we're the same amount of money, I don't remember what the compound amount is, but I'm thinking this is an investment for a year, and you have interest compounded quarterly at some particular interest rate. Notice here that if you compound quarterly rather than annually, you'll have $3,438.78. Now, if you weren't able to get that compounded monthly, then you would gain a few dollars, $3,443.86. If it's compounded daily, notice here that you actually gain less than an additional $3. And if you compound it every hour, you only gain a few cents more over what you did compounding it every day. So then the question comes up, suppose you have $2,450 deposited at 5.25% compounded continuously. Well, the formula for continuous compounding is actually a formula that involves E, where in this case E doesn't mean effective rate. E is actually a compound interest formula, but it's for continuous compounding. Now, rather than have to learn a formula, because we don't do formulas in this class, rather than have to learn a formula, what we will do is we'll figure out what number of compounding periods that it would take to compound continuously. Now the formula, which is given in your book, and I'll move forward and show you our problem. So returning to example 12, suppose that $2,450 is deposited at 5.25% interest compounded continuously. First, they want us to find the compound amount, and then they want us to find the interest earned after 6.5 years. And then the last thing they want us to do is find the effective rate. Now we can do all of this on the calculator. So where we will begin is we will begin with the TVM solver. So with the TVM solver, I'm going to skip over what N is first. We're going to fill in the other amounts. The compound amount is actually the future value. So the future value is something that we're going to have to solve for. And the present value is the $2,450. The interest rate is 5.25%. And this is going to be the interest earned after 6.5 years. So part of your number of compoundings is going to be 6.5 times the payments and the compoundings per year for continuous compounding. Now when you're doing continuous compounding, your P/Y and your C/Y are both going to be determined by 365 days in 1 year times 24 hours in a day times 60 minutes in an hour. And when you multiply those three amounts together, you will actually get the number, and you can actually put this calculation in P/Y or C/Y. But the number that you get is going to be 5,000 or 525,600. So then you're going to multiply that times your 6.5. And your number of compoundings then is 3,416,400. So then when we solve for the future value, the amount that we get is $3,446. And 43 cents. So the interest earned after 6.5 years turns out to be $996.43. Which is only $7.65 more than the amount of interest we had in example 5. And then in order to find your effective rate, we will go to the EFF menu, and we will enter in the stated interest rate, which is 5.25, and then enter in the 525,600 compoundings per year. Close the parentheses, and it turns out that the effective rate is 5.39%. The continuous compounding formula is the future value is equal to the present value times the number E. E is an irrational number. It's like pi. So since E is an irrational number like pi, the way that you access E on your calculator, should you decide to try the formula, is the second and the LN key. You'll see E raised to the X power. And in this case, if you want just E, then you would want E to the first power. But you don't really need to use this formula because there is a substitute that we can do with the TVM solver. going backwards. So this is a summary of the formulas that are used in this chapter so far. But we will use the TVM solver on the apps under Finance on your calculator. If you have questions, please post the questions in Shobi, and we will begin section 5.2 the next class period.